Yeah, we've definitely got the tropical moisture here in Texas. And the NOAA trajectory models bringing in a very deep tropical fetch from southern Mexico and the Caribbean. That right there is the trajectory for Dallas. There's the trajectories for Memphis right out of the Caribbean, and the trajectories for Atlanta, also out of the Caribbean. However, one feature that we see here is the extension of the Bermuda High into the Gulf of Mexico. Let me see if I can draw that right there. That's a ridge going all the way into Florida and extending into the Gulf. So when we run this forward, the moisture surges mostly go into Mexico itself and not so much up into Texas, although this next surge coming through Cuba and the eastern U.S., yeah, that gets lifted northward, so we should see quite a bit of tropical air across the eastern U.S. next week. Here's the upper level patterns for this morning. We're looking at the 250 millibar chart up at about 34,000 feet. 155 knot jet across northern British Columbia, and that marks the location of the polar front jet. See it located right there, coming into Saskatchewan and entering Montana and North Dakota. Now part of it is sheared off into a trough. We see that right here. That trough seems to be centered. I'm not sure if that's a closed wave or open wave. I might go closed on that. Yeah, it looks like it's around Durango to Alamosa and up to the Telluride area. Anyway, yeah, there's the base of the trough there across Arizona. So this is definitely not a monsoon type pattern. This is open westerlies. In fact, it's pretty much northerly flow. Now we can still get storms out of that because this will help with differential advection that'll bring cooler air in the mid and upper levels, which can give you a pretty prominent cold over warm situation. So although we can still get storms, it's for different reasons than what we normally see in August and early September. Down to the south we see a branch of the polar jet from looks like Kansas to Missouri out to Virginia. And the other thing that we wonder is, where is the subtropical ridge? It does look like it's evident east and northeast of Florida because we do have easterly flow coming on shore there. That puts the subtropical high off the Carolinas, but it's nowhere to be found in northern Mexico or the Gulf. So very likely that's far to the south. And that's one of the reasons that we're not getting a whole lot of easterly flow at this time into the southern U.S. And with this strong ridging out in the Gulf of Mexico and upper level ridging out to the northeast, that's maintaining that easterly flow right there. And as a result, that tropical storm down there in the Caribbean is likely going to move westward. And here we see the favorable ocean heat content in the northwestern quarter of the Gulf. However, our various forecast models are dead set on taking the tropical storm westward into Belize or northern Honduras. There's only a couple of outliers here, and that's the same old statistical models from yesterday. So we're not going to concern ourselves with the system any further unless it intensifies dramatically or makes its way into the Gulf. But for now, there it is, Tropical Storm Nana, 2 p.m. Eastern. Got 50 knots on that sustained. Central pressure kind of high, 1,002 millibars. And the official track into southern Belize there. Then it should dissipate as it gets over the interior regions. The special discussion just issued in the past hour has that for the most part being a tropical storm, and then it becomes a very low-end Category 1 hurricane as it reaches the coast. For the southeastern U.S., we can see that tropical moisture is streaming northward, and things are getting active in a lot of areas. We've got this MCS across northern Texas into northwest Arkansas right there. Large plume of anvil cirrus, and that extends all the way up into Illinois. And we got a couple of other MCSs here and there. There goes one across the Missouri Boot Hill And then looking down to the south, sea breezes and old boundaries still in place across Florida, triggering new convection in that area. And there's the surface map at this hour. For the most part, the entire area dominated by tropical air, so we can go ahead and put that maritime tropical symbol across that region. But it is broken up in Missouri and Texas by those old outflow boundaries and a couple of meso-highs helping to drive those. And there's probably another one right in there. We can certainly add that. And then up to the north, the polar front. And that's helping to drive the jet stream activity, which is helping to intensify some of the storm activity we have across the Midwest and the south central U.S. So we should probably get our skew-t proficiency up. Let's take a couple of samples. We'll try one around Waco, Texas, right there. We're going to try another one back into this outflow air over southeast Texas, and let's try another one further up the line, maybe towards Nashville. All right, so the Waco skew-t, that's showing some very deep moisture extending up to about 8,000 feet, but it does taper off from low 70s all the way down to mid to upper 50s at the top of that column. We also see a slight capping inversion, about 700 millibars, about 10,000 to 12,000 feet, and above that, not a particularly steep lapse rate at all. We do have steep lapse rates down on the low levels, and that's helping to promote some of the vigorous growth of some of this cumulonimbus. Now we do have some dry air in the mid-levels, and that's helping to enhance these decapes. So if we got storms, we would expect them to be kind of outflowish. And also with this very weak wind profile, you can see the photographs showing very little shear. That's going to cause a problem with storm longevity. So if we were to get storms, they would be kind of set up as clusters, and you would have a difficult time getting organization. Moving up the line into southeast Oklahoma, we can see that this is going to be within this MCS. So our skew-ts are going to be kind of weird. And the biggest thing that you'll see here is the omegas, the upward motion, showing some crazy upward motion. This is going to be a sign that you should not rely too much on this skew-t. And it is dominated by a lot of latent heat and high humidities. That's going to be in the cloud, so the data is not going to be all that useful. If you want to sample that environment, you're going to want to get out ahead of the line, like out here near Clarksville, Texas. And there you'll get a better idea of the parcels going into that storm. It does look like we have still captured a layer in a cloud, but if you hunt around and try to drop it somewhere else, you'll get into a much better representation of the low levels. And you can see up here near the Red River, we have picked up some higher winds, 30 knots there, and that's helping to lengthen the photograph in that region. And then Nashville, way up here in the corner, that should still be part of that tropical air, and it looks like there's less depth. It only extends up to about 4,000 to 5,000 feet there. And the lapse rate's not terribly steep, but conducive to some showers and weak storms. And then upper level flow, 30 to 35 knots. Yeah, that'll lengthen the photograph some, so you'll be able to get a little bit of organization of the cells in that kind of environment. The map in the northeastern U.S. looking like this. Low pressure in Michigan and around London, Toronto, Ontario. And we've got this stationary front extending along the length of that. And then out ahead of it, warm front in western Pennsylvania down into the Appalachians. That divides these 80-degree readings with very humid conditions from cooler 70s and upper 60s out to the east. And you can see a little bit of cold air damming there in Virginia. See that right there? Northeast winds, rain, dividing from these 90s way off the bottom of the map there and 80s out to the west. And that feature is there due to obstruction by the Appalachian Mountains. Then up to the northwest, a big change with a very powerful Canadian system in Manitoba and a strong warm front sweeping across the Dakotas. There's a satellite picture there. It's not all obvious where the frontal systems are. You can kind of make out a boundary somewhere in there. It's dominated by a lot of low and mid cloud. But down there in Pennsylvania and Virginia, we can see the effect of that blocked air mass helping to produce broken to overcast conditions in that region. And then where we have the very strong heating out here, that's where we have scattered cumulus clouds and more unstable conditions. There's the map for the northwestern U.S., showing the patterns getting very active. This system here coming out of Saskatchewan, this definitely has the appearance of an Alberta clipper, the kind of system we usually see in the wintertime. Conditions are a lot more moderate. Very warm for this time of year, so we're seeing mostly just 60s and 70s with a lot of wind, but it is a dry system. And then further out to the west, this also kind of looks like a winter pattern. Big old Pacific high coming in from Washington and extending into Idaho and the high deserts. Along with that, conditions are also mild. Lots of 60s on the map and only a few 80s out there in central Washington. And certainly looks like a nice day on in that region. We do see mountain wave activity right there in Montana. The telltale pattern of waves in the mid-levels. That's all going to be either high stratocumulus or mid-level altocumulus. And that's going to indicate some very strong turbulence through those levels. And then up to the north, we do see the cold air advection cumulus. There it is in Saskatchewan, and towards the very end, we do pick out a bit of a boundary starting to set up. Let's see, about right in there. So we could probably use that to kind of place our surface fronts. And there's our map for the southwestern U.S. region. Definitely looks like our Pacific front has managed to hold it together, crossing the interior regions. Bear Clinic Low right there near Gallup, New Mexico, with a front extending west towards Prescott to just south of Las Vegas. And you can see those northeast winds there. North winds in southern Utah and through Tonopah. That's definitely mild for this time of year. And that's that cold air making its way southward. But Red Bluff, man, they can't get a break. Every time I look at them, 94, 95 degrees. And that's due to that strong downslope from this higher terrain near Medford. And that hits the valley, warms up, and you get those hot conditions. But for the most part, San Joaquin Valley looking warm, but not too bad. And just a little bit of smoke and haze here and there with those wildfires. And then that circles us all the way back to Texas, dry line coming out of the Midland area, and we've got, gusty winds back behind that dry line, 50s dew points, and a little bit of troughing. I guess I could have thrown that in there. Yeah, why not? There you go. And you remember the upper level chart. Remember how we had that trough across southwestern Colorado, kind of like that. Then the upper flow went like that. And we sort of had a jet oriented like that. Now that matches up very closely with the surface front. See that right there? This is that kind of consistency we look for between the upper and lower level charts. So the deep troughing aloft, that's going to lie over the colder air. So we know that this part of the cold air mass is probably the densest, coolest part of that chunk of air, and likely that'll filter back in behind the system when it moves towards the east. And that also shows that these systems here have some upper level support. And with that troughing, that always means cold air aloft, and with that, the instability. And you can see those towers going up from Albuquerque to Gallup back towards the mountains on the Arizona-New Mexico border. And as a result, we got kind of a stormy day in that part of the country. But certainly a very dry front, and hardly a cloud to be found in Nevada, Utah, or California. Well, it seems that we've gotten so focused on the analysis, we're 16 minutes in, we haven't had a chance to look at the forecast. And there is going to be some weather. This is the latest high-resolution rapid refresh model. Don't have all the frames in, so I'm going to go back to 17Z. And it looks like kind of an active 24 hours here in Texas. A lot of convection going up west of Fort Worth this evening. Organizes into an MCS, moves towards Waco, Temple, and into East Texas overnight. So we're going to have a lot of boundaries in the area tomorrow. We can take that forward with the WRF ARW. And then tomorrow morning you can see MCSs in the Austin, San Antonio area. So yeah, that's one thing we're going to have to look at for tomorrow. Probably boundaries all the way down into South Texas. So once we have an idea what's going on there, we can pick up the national model. And you can see that the GFS for tomorrow, they've got storms forming out over the hill country into the area just west of Fort Worth. So that's where your knowledge of the boundaries comes handy. The GFS is not so good with that, but using your own idea what's happening, you can kind of adjust the models and take them into account. But the overall pattern, there's that big ridge into the Gulf. We got the flow coming around that ridge like that. And then we have this next system coming in from Canada. There it is right there. That's sort of like an Alberta Clipper heading towards the Great Lakes. This is tomorrow. And good grief, we're coming up on Thursday and Friday already. The main impact will be in the Great Lakes. Looks like it pushes that boundary down into the mid-Mississippi River Valley and into Texas, driven by this 1020 millibar high, which is not that strong, but it is very extensive. So that's going to be spreading all into the northeast U.S. and into parts of the south. So by Friday, we're going to be looking at something like this. You can see that high settling in across the Midwest, the boundaries pushing down to the Gulf Coast or even further south with that northerly gradient there. And then looks like a reinforcing shot coming southward right there. Kind of hard to see that, but that is another little Alberta Clipper coming south. And let's see what happens over the weekend. We return to pressure falls out over the high plains. Looks like another Alberta Clipper trying to come south there, but we're starting to open up the Gulf. This is over the weekend. And let's see what happens. Yeah, here comes that next one. This one organizes pretty well over the Great Lakes, driven by this 1024 millibar high. There's the fronts. That's not a dry line. That's an occluded front. Let's go back. Yeah, there we go. So, yeah, that moves over the Great Lakes, and the next boundary moves down south and stalls once again. And then we start getting, looks like just enough tropical moisture up to get these MCSs going. This is next week. I don't know how much you want to factor that into account, but there's the 540 line starting to rear its head. It's hard to believe, but yeah, I guess we're starting to cool down in some parts of the country. And that MCS moves south, and it even brings a 564, 558 line down into Texas. That could be the GFS cold bias, although this is in the 192-hour range, so this likely does have a grain of truth to it. So to me, it looks like maybe the second week of September, second, third week, may be on the cool side. And just taking a quick peek at the temperatures. Now, very likely we're not going to cool down a whole lot, because there's going to be a tremendous amount of air mass modification. Also, the GFS cold bias is an influence, but we can definitely see some very strong lapse rates with the strong modification, which means a lot of showery type activity, a lot of gusty winds out behind the front. And this is interesting. I don't know if this is going to pan out, but on the 9th, Thursday next week, it's showing 40s out there for, this is going to be highs out over Missouri and Iowa, and 60s all the way down to Texas. But our power bill last month was like $600, so I'm going to take any relief we can get. Well, it looks also like a ridge out west. That's probably the warm bias right there, but model going for 111 at Bakersfield. I think we can count on it being hot in that part of the country, unfortunately. Okay, well, that's about all I got for this evening. I appreciate you all watching and supporting the program. Take care, and we will see you tomorrow. Bye-bye.